Hello, dear authors and invited guests. Very good morning and welcome to the technical session 4B. It is my great pleasure to welcome you to the 5th International Conference on Information and Communication Technology for Intelligent Systems through Zoom on behalf of ICTIS 2021 and Global Knowledge Research Foundation. We are thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable circumstances of COVID-19 and making this conference more productive. Also, we wish everyone and their families a very protected time, and we all will pass this together soon. We hope you will enjoy 2 days of the the last day of the knowledgeful and interactive sessions. So just before we get started, I would like to introduce the chair of this session, Mr. Dr. Vijay Singh Rathore. He is the professor at IIS University, Jaipur, India. He has total 18 years of teaching experience, and the areas of his interest include cloud computing, IoT, big data, security, artificial intelligence, and machine learning. Thank you so much, sir, for chairing the session.
Thank you so much.
Now, I would like to start with papers. Also, there is a special note for the presenters. You will be given 8 minutes for the presentation, and rest 2 minutes will be for Q&A. On 7th minute, we will raise a gentle reminder. On the 8th minute, your presentation will be over. And I request while the presentation is going on, other participants kindly be muted. So our first presentation is, just a minute, I'm sharing my screen. Our first presentation is from Mr. Dushyant Singh B. Rathore. His presentation is about future-oriented smart village model using advanced IoT sensors-based technology. I guess Mr. Dushyant is not here. Can we go ahead, sir?
Yeah, please.
With our next presenter. Our next presentation is from Mr. Madhur Garg. His presentation is about design and FPGA implementation on Vedic notch and peak filters. Hello, Madhur.
Good morning, everyone.
Yes, sir.
Should I share my screen?
Yes.
Yeah, thank you.
Your screen is not visible, Madhu.
Yes, sir. Just a moment, sir. Yeah, sir, please confirm if my screen is visible now.
Now it's visible. Yeah.
Thank you, sir. So, as discussed, the topic is design and FPGA implementation of pitch and notch filter using Vedic multipliers. So, my co-author is Dr. Meenakshi Agarwal, and we are from BML Munjal University, Department of ECE. So, in the introduction, so a filter is a circuit that is used to model or shape the incoming frequency in any desired manner. And it is commonly used in applications such as radio communication, audio electronics, and certain medical devices. So in digital filters, what we use, the multiplication and the addition form the two major components and of the function. And the complexity of these circuits determine the performance of the filter, the power it will consume, and the hardware that it will be occupying. So the objective of our work is to deal with such complexity to strike and balance, a good balance between the performance, the power it will be consuming, and the hardware it will be requiring. So what are the existing challenges that we are facing these days. So as we know, the devices are, we are trying to make the devices as compact as possible. And also the transistors the transistor scaling is going on, which has increased the power loss. So when the power loss is increasing, the devices are getting heated up. So there is a demand for improved sorry, there is an heat removal mechanism also, but a separate heat removal mechanism again increases the hardware, and then becomes uh, and then it becomes a blockage in compacting our devices. Also, if the power loss would be more, the battery life would be less. So people want that their devices should be having a better battery life and performances. Then new technologies such as 5G and IoT are emerging, so they need a better processing of signals for accurate outputs. Then in medical field like ECG, we are using the sensitive the filter for the ECG would be, the better the output, the better it will be diagnosing whatever the heart pulses are. Then the audio equalizers, the better the filters used in the equalizer, the better would be the audio outputs. So what we have done is, to address all the concerns, we have proposed a new design for the peak and the notch filter using the Vedic multiplication. And we have compared the performances using the three basic adders: the ripple carry adder, the carry select adder, and the carry save adder. And the performance on the basis of power and hardware is then compared. So what has been a methodology? So in our method, what we have taken is a 8-bit fixed point power, low power Vedic multiplier, Vedic notch and peak filter, which we have addressed as VNPF. So the 8-bit Vedic multiplier, the multiplier itself has been designed thrice. First using the ripple carry adder RCA, the carry select adder CSLA, and the carry save adder CSA. And the same adders have also been used along with the three different Vedic multipliers in the filter architecture itself. So it's completely, we have designed the filter has been designed 3 times using 3 different adders. So this is the basic structure that we have used to design a second order IR peak and notch filters. So here the AZ is representing the transfer function of the all pass filter. So we have designed the peak and the notch filter using the all pass filter, so that we get a mirror image of the numerator and the denominator coefficients that I'll be discussing further. So this is the complete filter, how we have designed the same signal that the input signal passes through the all pass filter, and then it splits to the two adders. One is adder, one is and other end it is getting subtracted, and then we get two outputs for notch and peak through the same structure. So the transfer function for the peak and the notch for the all pass filter is AZ of then this expression. So these B0, B1, B2, A0, AZ, A0 and A1, these become the mirror images, which I'll be discussing in our results, that we have got using the all pass filter. It becomes easy and to implement these numerator and denominator coefficients. So some terms related to the filter parameters. So the notch or peak frequency, the frequency that is attenuated most by the filter. The lower cutoff frequency below, it is the frequency below which every frequency is allowed to pass. Then upper cutoff, the frequency limit above which all the frequencies are allowed to pass. The bandwidth, it's the difference between the upper cutoff frequency and the lower cutoff frequency. And the quality factor, it determines what will be the attenuation of the notch or the peak frequency at the -3 dB cutoff points over the null frequency. So it is determined as bandwidth by notch and peak frequency. So let me discuss about the Vedic multiplication. So Vedic multiplication that we have, this Vedic sutra that we have used is the Urdhva Triyagyam. So here, these lines that you are seeing. So first, if we go from LSB to MSB, first, the first bit of A1 and B1 are multiplied and a partial product is generated. Then A1 is multiplied with B0 and A0 is multiplied with B1, and another set of partial products are generated. And then A0 is multiplied by B0 to generate the fourth partial products. And these partial products are then added using the relevant adders. So this 2-bit Vedic multiplier, since it is generating the four partial products. So we have used the half adder to add those partial products and get the final final product values. Then using the 2 into 2 Vedic multiplier, we have generated a 4-bit Vedic multiplier, and these the blocks that I'm mentioning, 4-bit adder, these have been replaced using RCA, CSLA, and the CSA. The same has been done with the 8-bit Vedic multiplier, where the 4 into 4 Vedic multipliers have been used to generate the partial products. It is a modular approach that we have used. Then 8-bit adders are again the ripple carry adder, the carry select adder, and the carry save adder. So the results. So the filter was designed for the following specifications. The notch frequency or the peak frequency was 50 hertz that we have attenuated. The sampling frequency we have taken 150 hertz, and the quality factor has been taken as 20. So the bandwidth we obtained was 0.0333. So as I told that the numerator and the denominator coefficients would become in all pass filter the mirror images of itself. So as we see, these are the values that we have obtained for the denominator and the numerator coefficient. The numerator coefficients for B0 are 0.9576, 0.978, and 1. And for the denominator, it is just the mirror image of 1, 0.978, and 0.9576. So this has just reduced our complexity in implementing the multiplier and the filters. Sorry. So this is the frequency curve that we got for our filter. So the blue line tells us the notch frequency, and the red line is telling us the frequency response of the peak filter. So in the notch frequency, where the line goes very narrow, is the frequency that is being attenuated by the notch, and the red where it goes, the heap is shown, it attenuates that frequency by the peak filter. So these are the pole and the zero plot for the peak and the notch filter. So we can see that our zeros are lying on the unit circle and the poles are lying just inside the circle. So telling that our filters are stable. So this is the output of the Vedic multiplier that we have implemented. So we have given certain values, like you can see is IP represents the input, and the inputs are 62, 63, and 64, 65, 66. And the next is the first is the multiplier, so the second is the multiplicand, and we have given certain more values to the multiplicand. And we can see that the yellow line is representing the first output, and 63 into 148 is 9324. So the OP is representing the output of our Vedic multiplier. So this is the output for our filters that we have designed in the bits. What we have got, so the input, we have given the input the input is signals, which is the digital input, and our filter has provided us with the 2 digital outputs, the OPN, the notch filter, and the OPP as the output for the peak filter. So this is the output for our filters. So now our results using we have used a Verilog and to determine outputs for a filter and comparing the performances. So VNPF, Vedic notch and peak filter, using CSA is the total available slices were 13,300. So for our evaluation, we have used the FPGA of Zinc 7000 XC7Z007 CLG400. So the slices available were for the 13,300 using carry select adder. The filter used 40 slices, carry select adder used 37 slices, ripple carry adder used 37 slices, and the conventional were using 48. The LUTs, the available LUTs were 53,200. The carry select adder used 140, carry select adder used 131, ripple carry adder used 121, and the conventional was the 146. The registers available were 1,64,400. The carry select adder used 30, CSLA used 30, ripple carry adder used 30, and the conventional was 30. So no change was seen for the registers. But the power for the carry select adder was 26.05 watt. Carry select adder was 26.69, and ripple carry adder was 25.09, while the conventional was using 29.08 watt. So the conclusion from our study, it is noticed that the proposed VNPF have better performances compared to the conventional notch and peak filter. In addition, the VNPF have been designed using the 3 adders, carry select adder, carry save adder, and the ripple carry adder, and the performances have been compared. And the conclusion is, for the power consumption, the carry select adder based VNPF is lying between the carry save adder VNPF is lying between the carry select adder and the ripple carry adder. But the carry select adder VNPF is utilizing smaller hardware compared to the CSA based VNPF, but more than the ripple carry adder. For both power and hardware consumptions, the ripple carry adder based VNPF is the best because it is using the less power. However, the RCS offer a large delay and the large words length, which has already been established through various studies that the ripple carry had a lot of delay because the carry has to be communicated through various adders. So where the higher speed applications, if we are using for a higher speed applications, the carry select adder based Vedic notch peak filter can be preferred. And on the other hand, where the low complexity is needed and speed is not a major factor, so ripple carry adder based VNPF can be used. Thank you.
May I know your name again, please?
Madhur Garg.
Yeah, Madhur, your presentation was very nice, and the way you your experimental setup and your like analysis of the results and discussions was very nice. But I have one suggestion. Like you just mentioned that you have compared your work with the conventional notch only. Other
Yes,
than
sir.
the conventional notch, have you also studied any existing studies going on similar way on your similar objectives? And have you compared that study with your work?
So
Uh,
when we were just
As
going,
as compared to conventional laws, it is very nice. Your
yes, yes, yes,
VCNF
sir.
is, sorry, VNPF is very nice. But
Yes.
I think this parallel to VNPF, there must be some other studies going on. So have you studies, because you have not mentioned any literature review in your PPTs. So have you done that literature survey or not?
So, sir, actually, when we were doing the studies for our project, so where the majorly authors have stopped their studies at the Vedic multiplication or addition itself, but we couldn't find anything which has been implemented to the notch and the peak. So it is the first time we considered that this work would be the first time that we have implemented those Vedic filters to, the Vedic multipliers to implement the filters.
But there must be some complexities attached, because if others are not using that particular thing which you are using, there must be some complexities. Have you studied those also?
So,
Why others are not using Vedic filters?
yes, sir.
Like
So,
if you have gone through the existing
yes, sir.
literature, you must have
Yes,
seen
sir.
that others have not been using this Vedic filters, and you are using this Vedic filter. So can
Yes,
you
sir.
tell me why the other researchers are not using and why you have used Vedic filter?
So, sir, we used this Vedic multiplication because the Vedic multipliers have proved to be less complex and giving a faster outputs. So, some challenges through this Vedic filters was that the signed multiplications and the like we have used for the smaller bits like 8 bits or we for the 8 bits. But if you go to the higher bits like 1024 or 2058, so there the complexity arises. So that study can be further taken up.
Okay, my advice is that you just go through some literature review, the
Okay, sir.
existing literature review.
Yes, sir.
Okay,
Yes.
and similar to your work, then you will
Okay, sir.
come to know what exactly is going on in your field,
Okay, sir.
and
Yes,
then
sir.
you will
Yes.
be, you can also improve your work accordingly.
Yes, sir. Yes, sir. Yes,
Otherwise,
sir.
the work seems very nice. Presentation is very nice, and the
Thank you,
way
sir.
you have given your reports is very nice. Congratulations.
Thank you. Thank you, sir. Thank you, sir. Thank you so much, sir. Thank you, sir.
Okay, fine. Neela madam, we can now invite the next person.
Yes, sir, sure. Our next presentation is from Ms. Gunjan Singh. Her paper is about a comparative study of recent feature selection techniques used in text classification. Hello, Ms. Gunjan.
Yeah, a very good morning to all the professors and the team here. Today I'm here to present on the topic a comparative study of the recent feature selection techniques. Before I proceed, I would just want to ask whether should I go ahead to start on the video or should I start presenting my screen?
You have video also to show?
No, sir. As in my video, is it required or just the? Okay. Very good morning,
Okay,
sir.
fine.
Very good morning.
You can just share your screen and you can start speaking.
Perfect. Thank you so much, sir. Thank you.
Okay, fine.
Okay, so as I discussed, the topic is a comparative study of recent feature selection techniques used in text classification. So I am Gunjan Singh, the research scholar with GD Goenka University, and the co-author there with me is Professor Dr. Rashmi Priya, who is associate professor with GD Goenka University. So the content of this particular presentation, it includes the title, abstract, introduction, literature survey, research gaps, results and discussion, conclusion, and references. So this title, as this I have discussed already. Now moving on to the abstract. Now these days handling large amount of data is a problem, and we do have lots of resources to store, train, and process the information. Still, it is very much required to scale these data sets in order to reduce the computational complexity, save time, cost, and to retrieve valuable information from large text documents, as the performance of a machine learning algorithm depends on the data set used. So in order to do that, we have certain techniques wherein, you know, the pre-processing of data is required to compress and analyze the data for the aim of text classification that can be achieved by using feature selection techniques. So the main objective of these feature selection techniques is basically to spot relevant features and take away redundant feature from the high dimensional data. So some of the keywords that have been used in the paper are feature selection, text classification, filter method, wrapper method, text mining, dimensionality reduction. So the introduction that includes well, the mining of useful information hidden in the text, it gets benefited from the text classification. So it basically aims to assign the text document with the unknown classes to a fixed number of classes by particular classifiers. Now the text classification, it assigns the text document to the appropriate categories, and also it is all known as text categorization, which is a classical problem in NLP, which is natural language processing, and it aims to assign labels or text to textual units like sentences, queries, paragraphs, documents, and it can be either performed through manual annotation or by automatic labeling. However, with the growing scale of text data in industrial application, automatic text classification is becoming increasingly important. Now, there are several applications for which text classification can be utilized, like identification of particular topics, complaint feedback of particular services, besides that TV program, audio music genre classification, besides that accident detection for disease outbreaks, and we have evaluation of essay answers and classification of materials of different reading levels for college students, recognition of severe pediatrician asthma, and email filtering, email classification, web page classification, author gender identification, and topic identification. Basically, the size of the feature vector, that is feature vector of a text corpus, that is incredibly high. So we need to reduce down that particular text corpus, and in order to do that, we need to apply feature selection technique so that it reduces the irrelevant sounds and other things, so that, you know, data is reduced down to what we require. So in order to get rid of redundant and non-informative variables from data set, basically it is divided into 4 categories, which is filter model, wrapper model, embedded model, and hybrid model. So this filter model, it rapidly eliminates irrelevant features. However, it fails to eliminate redundancy between the features. The wrapper model, it gives better performance. However, it is time consuming. When it comes to embedded model, the feature selection and learning algorithms are interleaved in embedded methods. There are 3 kinds of algorithm in embedded approach, which are exponential algorithm, sequential algorithm, and randomized algorithm. And a hybridization model could be, you know, combination of different techniques which can be combined together. So here in this particular presentation and the paper also, I have discussed about the few very recent techniques for text classification, which are ISCA, improved sine cosine algorithm, besides that quadratic programming based numerical optimization approach, normalized difference measure and binary optimization algorithm, Hebb rule based feature selection, active learning based support vector machine learning, besides that line fuzzy network, neural networks, relative document term frequency difference, and limited memory Bryden, Fletcher, Wolfram, Shannon algorithms. So this paper is actually comprised of 4 sections. The first one is the introduction, then a literature review, then results and discussions, and then the conclusion and the future scope. So this literature survey, it consists of again the 8 subsections which I have discussed just now, with all the 8 techniques for feature selections. And there is a table also which is there to point out the comparative study of the recent feature selection techniques which have been mentioned. So it basically this includes the introduction of all these techniques. If coming to the ISEA, so what happens is in SEA, which is the sine cosine algorithm, it gets limited to the exploration of the search space. So for this particular problem, to extend the search space, to extend what happens is the it gets stuck in the suboptimal regions to get the best performance. So in order to find the solution from further region of search space, there should be an algorithm, and hence SCA was introduced to improvise the diversification of SCA in order to discover new regions for search space. And then is quadratic programming based numerical optimization approach, which is used to reduce selection of redundant terms by using the term similarity. Now the priority is given to the independent term to avoid redundant terms, and it can be used to consider a balance between ranking and similarity terms for appropriate term selection from global perspective. Then comes NDM BJO, which is normalized difference measure and binary GI optimization algorithm. So it is a hybrid feature selection method basically, which consists of BJO, which is binary GI optimization algorithm. It is a wrapper based method, and this normalized difference measure, it is a filter based method, and it is used to reduce the computational cost and increase text classifier accuracy. So naive Bayes and support vector machines have been used as the classifiers here. Then the fourth technique we have discussed is Hebb rule based feature selection. So here it is completely based on supervised Hebb's rule, and it is one of the main neural network learning laws, which expresses that when an axon of a cell A is close to enough to energize a cell B, and more than once or industriously it partakes in terminating it, some development cycle or metabolism change happens in one or two of the cells, such as A's effectiveness joint of cells terminating B is expanded. So the prejudicial term can be related to the perspective on neurotransmitter between the neurons. Then the fifth technique we've discussed is SVM, which is related to the active learning method using support vector machine. So it is a supervised learning algorithm, and it requires manual labeling of data samples during training, which is time consuming and error prone task. That's why the technique of active learning is discussed, which can reduce the labeling effort by intelligently selecting the sample to be labeled without compromising the accuracy of classification. The batch of informative samples using posterior probability provided by a set of multi-class SVM classifier, it is selected by this method, and these samples are manually labeled by an expert. The sixth technique discussed here is the LFNN, which is line fuzzy neural network. It is again a supervised learning approach, and it uses context and sense-based feature extraction and hybridized fuzzy neural network. For this connectionist model, the feature selection is based on entropy function, and extraction process utilizes a semantic word processing along with contextual approach and topic terms in order to extract the relevant information, which is basically in terms of words, and it modifies BP line, which is BP, which is a neural network technique by incremental learning of BP line neural network, named line fuzzy neural network. So it integrates fuzzy bounding to design hybrid fuzzy neural network, and the optimization algorithm is adopted to select optimal weight and LA for updating the weights of fuzzy neural networks. So this classification approach is called evolutionary classification because the dynamic based database is considered in this, where the classifier can learn the model dynamically depending on the new database. So the next technique, the seventh technique which has been compared here, is the relative document term frequency difference method. So here then what has happened is it comprises of 4 methods. It basically adds all the feature to the original feature set, and then all the features are divided into positive and negative feature subset according to positive or negative values of the weighting to improve the high class relevance of the features and reduce the correlation between the features. and then it reduce the search range of feature space and maintain appropriate feature redundancy. And then it ranks all the features as per weights. The positive feature subsets are ranked in a descending order, and negative feature subsets are ranked in ascending order. With some search strategies, the candidate feature subsets are selected from two independent feature subsets. Now, the eighth technique that has been discussed is the limited memory Braden-Fletcher-Goldfarb-Shannon algorithm. It is an artificial neural network, which is a quasi-Newton procedure for multi-label, multi-class text classification. And this numerical unconstrained training technique, the multi-label extension of log loss function being used in this particular ML BFGS technique, it provides a noteworthy opportunity for text mining and leads to significant improvement in text classification performance. Now, the training approach is applied to allocate some of the classes to each correspondence sentences from different available labels. It has a less computational cost, faster convergence rate, and much accuracy in corpus analysis. Now coming to the comparison table for all these eight techniques that I have discussed just now. So herein I have mentioned the author in which the year had these have been published.
Sorry
So,
to interrupt you, ma'am, but you have exceeded the time limit.
all right, ma'am. Should I complete this table then, or should I
Yes,
jump on to the
yes.
conclusion? All right.
Whichever is fine.
Okay, thank you, ma'am. Thank you so much. I will just move on with the conclusion then. So this is the table that has discussed about the recent feature selection technique. So all the papers which have been discussed as a reference, they have been taken, they are very recent from 2020. So we can have the view of all these techniques, and all the evaluation metrics, techniques compared to database consideration, advantages and disadvantages have been thoroughly explained here. And there are few research gaps here, like quadratic programming method. It reduces the number of redundant terms selected and improves the categorization accuracy. And in the task of text classification, how to remove the noise in a larger amount of text data, such as irrelevant and redundant feature, that is a challenging topic. So we have achieved deep learning and machine learning. They've achieved the higher accuracy on tasks ranging from sentiment analysis to topic classification. But high performance often depends on the size and quality of training data, which is often tedious to collect. And most of the existing research on traditional text classification centers on one special type of phrase of sentences. So unlike a paragraph or document, short texts are more ambiguous, and since they have not enough contextual information, and it poses a great challenge for the purpose of classification. So this is the results and discussion which have been mentioned, wherein all these techniques have been utilized, and a few of the results that it shows, which have concluded that artificial intelligence and machine learning is yet an arising field, and there has been a great deal of work going around in this area, and it has tons of scope for future work. Hence, it can be concluded that if ISCA, which is improved sine cosine algorithm, is simple in concept and is capable of providing good performance for updating the solutions position that can be helpful to adapt with a broad range of search problem, as it provides flexibility with some parameter settings. However, the quadratic programming based numerical optimization finds an ideal harmony between two conditions for feature selection, wherein the label similarity lessens the quantity of repetitive labels chosen to enhance classification correctness. And the third technique, that is NDM-BJO, it lessens the high dimensional attribute expense to enhance the classifier exactness, and this can diminish the unpredictability of feature selection, as it tends to be done as matrix operation. And active learning based support vector machine, it expands the classification accuracy and holds generally excellent strength with all the data sets. Now, line fuzzy neural network, it has better accuracy, and it is further required for processing to minimize the error rate. And RT-TDF, it is more robust. And the last technique, which is the MLBFGS, it helps in incrementing the performance of text classification. Consequently, we can hybridize the characteristics of all these algorithms to refine the individual impediment, which can give us the extension for future work. So these are all the references that I had referred to. Thank you so much for your valuable time.
May I know your name again?
Yes, sir. My
Gunjan.
name is Gunjan Singh.
Gunjan, yeah, Gunjan. Can you tell me
Right,
what
sir.
is your topic? Can you come on the topic slide? What was your topic?
Okay, sir. Sir, my topic is a comparative study of recent feature selection techniques.
Okay, comparative study.
That's
Fine.
right, sir.
So in your comparative study, you very well mentioned your different papers in your literature review, and the
Right, sir.
special thing is your tabular format which we have used. Very nice. So because in tabular format we can analyze all the papers comparatively along with each other. So
Definitely,
that's
sir.
also very nice.
Thank you so
But when
much,
we
sir.
come on the yeah, good. But when we come on that compare just results and discussions.
Right,
So
sir.
I think in your study it is only comparative analysis. So what results and discussions you are talking about here? Can you come on that slide?
Definitely, sir. I'll just cover that
So
slide.
normally when we perform some experiments or we do some modeling or we make some simulations, then only results and discussions can come. But in your study, it is only barely analysis of the existing literature only, and that you have already
Right.
given in your tabular form and your conclusion. So in result discussions, what you are telling, just come on that slide.
Yes, sir. I'm just coming on that slide. I'm just trying to come on that side. Just a second, sir. Okay.
I think your screen is
Yes.
not visible.
I think, sir, it will be visible now, sir.
Okay, okay, fine.
Okay. Uh, just a second, sir. Sir, is this screen visible now?
Yeah, now it's visible. Come on that results and discussion slide.
Yes, sir. Definitely, definitely. So, sir, what has happened is actually this was a long topic and I was there, so that's why, considering the valuable time, I could, could not proceed with it. Yes, sir. So this result and discussion, it basically there have been, certain testing that has been done on different kind of data sets. So in each of the techniques, this.
I just want to know who has done the testing. You yourself, or you are just showing the testing of some existing literatures?
Sir, I have concluded it from the testing of the existing literature. So I am yet to done on testing or this particular. There are certain hybridization techniques that I'm working on, and I am taking considering few large data sets, the real time data sets, and I'm doing testing on that based on Python. So it is in the process as of now. So all these testing and everything, I have taken the reference from the very good papers and I have quoted it them here.
That is what I want to tell you, that you can just mention here your proposed model, your proposed like whatever you are going to propose. But here, when you say results and discussions, it shows that you have done all the experiments, you implemented your model, then you have like executed your model, and then there are some outcomes of the model, and you are talking about the outcomes of the particular model. But that has not been developed so far. So I think
All
this slide
right.
you can reconsider. Otherwise,
Sure,
as a
sir.
comparative study,
Perfect.
it's very nice. Fine. And one more thing you are telling in your future scope, because
Yes, sir.
when we have not done any experiments or not make any model, so how can we ask about future scope? It can be your proposed work. Like you can tell that is my objective for the proposed work is this, but future scope will come when you will done with your project.
All
Okay.
right, sir.
So
Perfect.
you can come on your conclusion and future scope. That next slide,
Yes, sir.
conclusion and
Okay. So here it is.
here is last one. You are telling that you have this we want to do something hybrid and something like that.
Yes, sir.
So
I
I
have
think
been working on certain techniques. So the recent techniques I've been working on, it's like the SORM optimization. Besides that, invasive weed technique. So I'm just trying to hybridize these techniques, and I'm working on the real-time data sets in order to get the results. So it shows like better efficiencies. So
that is okay,
yes.
but you are trying to put, I think, your all research work in this paper only. But this paper is mainly only for the comparative study, because the topic of the title of the topic is comparative study. When
All
we are
right,
talking
sir.
about comparative study, you just put only comparative study, the existing literature, the limitations of the existing literature, conclusion about your existing literature, that you can do. But this future scope and results and discussions, these all you will, I think you can mention in your another next paper, when you will
All
tell
right.
about your proposed model. Okay.
Perfect,
Otherwise,
sir.
the work is nice.
Definitely. Yeah.
Okay, fine. All the best.
Thank you so much, sir. Really thanks for the inputs.
Yeah, Nila madam, now we can invite the next
Yes,
one.
sir. Yes, sir. Sure.
So,
Thank you, Miss.
can I leave the meeting, or do I need to continue here? I can leave.
Yes, you have to continue, ma'am.
Okay. Thank you
Madam,
so
please.
much. Thank you so much all for your time.
Our next presentation is from Ms. Poonam Prashant Katyare. Her paper is about electricity anomalies detection and automation in smart meter system. But I guess she is not available.
Okay. Invite the next one.
Yes. Yes. So moving ahead with our next presenter, Ms. Monica Arya, and her paper is about a novel deep ensemble learning framework for classifying imbalanced data stream. I guess so she is also not available. Also
You may call
moving
next.
ahead. Sorry, sir?
You may call next one.
Yes, sir. Yes, sir. Okay, our next presentation is from Mr. Kripal Joshi, and his paper is about customer behavioral market basket approach for most frequent pattern identification using data mining techniques. He is also not available, sir.
Okay.
So, as the rest of the presenters are not available, sir.
Okay.
So, can we wait, or should I? Okay, just a minute, sir. Yeah,
Poonam is
yeah.
coming.
Yes, Poonam is in. Hello, Miss Poonam. Just a minute, sir. Hello, Miss Poonam.
Yes, miss.
Ma'am, you can start your presentation. It's just right your turn.
Yes. Actually, I have joined another link, ma'am.
Yes, yes, I got it. Please, now you can go ahead.
Yes. Okay, ma'am. Whether my screen is visible?
Yes, it is visible.
Yes. Good morning, all. Actually, the topic of this presentation is the electricity anomalies detection and automation in smart meter system. This is actually the major topic where the electricity is mostly used. And now in a digitization era, the every activities depends on the presence of electricity. So this electricity plays a vital role in industry, society, and household activities. As we know that the various activities like various sectors like commercial, transportation, residential, and industrial sector, everything is depends on the electricity. And in this now pandemic situation also, we need the electricity at every moment, as everything is going on work from home. So the major and vital role is played by the electricity. So the electricity usage and the supply is a major problem here. So which I have analyzed here. The major is the usage of electricity, whether it is get used perfectly or not. This measurement is not there in a reality. Our electricity supply grids, that is our smart grids, they provides us the electricity, and the consumers consume that electricity, but there is a gap between the consumption and the utilization of that electricity. So this is the major focus and the major area where the more analytical part is required regarding this electricity consumption. And one more thing, along with the consumption, there is a theft. So we have to analyze what type of technical losses are there, what type of theft is there in the electricity consumption. So this is the major area where the analytical minds and researchers are working on this study. So various techniques are available to detect this electricity theft, as using the machine learning techniques are there. So there are actually the two aspects of this electricity system. First is related to the infrastructures, means we can provide the hardware support, and the second is related to the software support. Like under the hardware support, we are seeing the wireless automatic meter reading systems with the wireless sensor networks from the smart grids are used for the measurement of the consumer's consumption. And it will help in the reduction of the cost of human readers, reduction in the peak demand of energy, the time of use bill generation, and benefit of the customer, as they can shift their demand to the off-peak times and the actual real-time pricing model. Means the first support is given in the form of hardware, and the second support we can give in the form of software. So whatever data is coming from that smart grids, or whatever the public data usage is there, accordingly we can apply the analytical minds in that, using our machine learning and deep learning models. The various researchers apply the various techniques of machine learning on that data and analyze try to analyze the consumptions and try to find out the abnormality in that consumption. So here, actually, this is the existing scenario where the number of researchers uses the support vector machine classifiers, then disjointry classifiers, extreme gradient boosting classifier, then conventional neural network, logistic regression, deep conventional recurrent neural network, RNN, based on the detector clustering algorithm, then LSTM, detection of the abnormal patterns, and the fusion of that deep learning with the random forest techniques also. So number of algorithms they have applied on that data set. But as for each and every case, there is some limitations. So limitations of the existing study is like the existing machine learning algorithms as this SVM, decision tree, random forest is inferior in case of a large data sets. The problem of the class imbalance and the manual feature selection are found in many studies. Most of the cases use the data set which has the large amount of missing data with the outliers. And the data imbalance, this is the major case which found in most of the studies. Well, because that the consumption data is always available in the form of monthly reading as well as daily reading basis. So 1D and 2D data is available. So accordingly, the imbalance of the data is a major problem in that study. Then a hybrid model, lots of the researchers uses the hybrid model with the CNN and the LSTM with the imbalanced data set. And then overfitting and underfitting that problems may occur in that case. So another hybrid model with CNN with the RF is also used, where the CNN used for the feature extraction and RF used for the classification. But this requires again the high execution time. So these are the limitations of the existing study. The proposed system, what we have planned as the whatever the smart meter data is there, like this, why not to use that data with this wireless sensor networks? That data is already available in on that servers through that meter reading. But this meter reading we have proposed that this meter reading is through the image processings. We are going to use the image processing in this case, while that data is get read through that image processing optical character reading, and then automatically that server, that a smart grid server contains that data. We have to read that data through that server and then apply our machine learning model. So it's a hybrid combination of software and hardware, and then apply the pre-processing, apply the data filtration process, then splitting of the data and training and testing, data modeling, and then calculate the performance of the measurement. So here this data filtering is also plays a vital role, where this in the data filtration technique, we are going to apply the classification algorithm. But again, for the classification, because whatever data we are taken from this smart grid, these are unlabeled data. So we have to label it. So for the labeling of the data, means we have to classify it. For that, we required the clustering. So we are going to use the clustering, which bifurcate us into that data set as a normal and the taped user. So this second step, and this is a filtration step, plays a very important role. So it uses the clustering algorithm, which is the input to your classification algorithm. And then the classification algorithm converts and bifurcate that users into normal and theft users. That classes will get labeled into the data set, and then it that classification algorithm, then comparison of the various classification algorithms under this classification process is there, and then evaluation of the classification techniques are there. And finally, what we thought, why not to use a billing system over here? So generation of the electric bill amount, because unless you got this consumption metering values, you are there. Consumption metering values are there. So you make a use of that metering values and then find out the electricity bill amount directly. Is calculated. So in this way, this is a projected work where it's a combination of the meter data, pre-processing, filtration, classification, evaluation, and then generation of the actual electricity bill. This is a combination of all the classification clustering algorithms, and this is the conclusion. So in this work, actually, this is a review, whatever the study is going on this electricity consumption and anomaly detection, and why not to make a use of all that existing study and then propose a new work, and which will be the better usage of the all the techniques, that is technical analysis as well as the hardware usage. So this is our study. In this work, we will attempt to read the smart meter data and filter data for the classification, and then ML algorithm we have to use to classify the users, which will get designed, developed, and compared with the other solutions. And we are going to create a software or the automation into which generates the electricity bill amount, which will be developed and accessed. So this is our study. Yes.
Yeah, may I know your name again?
My name is Poonam Katariso.
Yeah, Miss Poonam, your objective seems very nice and relevant also. But can you tell me, like, have you gone through some literature review in the area?
Yes, sir. Yes, sir. These.
Okay. Can you mention one or two like base papers?
Here.
Motivation for your research.
Sir. Actually, here the number of papers which I have gone, that are nothing but the existing this research. There are two types I have gone through, where the first papers which gives us the infrastructure utilities, like how the smart meter is reading and the consumption, and what is the use of that wireless automatic meter reading. This is the first aspect. And second, in literatures, I got the papers which are related to the directly the classifications on that metering data. So these this second software support, these are the nothing but the literature surveys where the various researchers uses this support vector machine that all classifies exhibits decision tree. But what happened then, data set is very small. So I have gone through the data set also. Number of data set are available, public data set are available. But why not to directly go for asking for the actual real data set? So this is our target. First, we are going to ask for the actual data set because they want why you are required this data set and that everything that now we are in pipeline with that. So we are sorting out, and then we get the actual data. Why not to use the real data set? Because everything public data set are available, but this data set size is very small. Like under this SPM, and they have used the SPM decision.
Okay, fine. Actual data set, like what do you want to say with the actual data set? Will you get the data set from the electricity department or something? What will you do?
Yes, sir, that MSCB, and that we are going to apply for that because they said ki.
For that also you need to just decide like from where you are going to get a data set. You're going to get data set from some city or from some state or from national level. What level data set you want? Like how?
Yes, sir, region wise. Yes. Yes, sir, region. Yes, sir. Yes, region wise. First of all, for the small region like where we are here in Pune, and again we are going to see the region wise.
For that purpose, I think you can use that sample data set. There is no need of the actual data set.
Hello, sir.
Why do you specifically need actual data set? Like
sir.
The sample data set can also be used. It is available online.
Yes, sir. Yes, sir. That data set is available, but what happened? Whether whatever the data is available, that is already labeled data set, sir. In that case, the label is assigned. Means whatever is the type, means like residential consumers and non-residential consumers. This type of data is also available. Already they have bifurcated that data. So, but I want
what I have observed here, like you have done the journal study, very nice. But specifically, if you want to design some meters or you want to generate the bills also of the meters, you want to use some sensors with the meters, and for that, I think you should just review the literature of some existing like models which are actually working. Fine. Okay. And from those models, you can find out the limitations. What are the actual limitations? and then out of those limitations, on what limitation you want to work, because as a generalized, you cannot change the whole system. But in the
Yes,
system,
yes.
we can identify some loopholes, and those loopholes or those your future work, you can just identify one or two things, and then you can start working on that. Okay, that's
Yes,
my suggestion only. And
yes,
one
yes.
more thing, you mentioned that the meter readings using image processing. So how will
Ah,
you use that meter reading with the image processing? Any example?
sir, actually, the sensors are there. Na sensors, when we are going to use means no need of that actual human readings. So directly we captured that image from the consumer's place, and from that image,
Sensor will capture the pictures, okay, the image, and from image you will
yeah,
process the meter readings.
yes, sir.
Okay, fine, fine. And then you are also asking, mentioning about bill generation. So bill generation is also already available there. So what modification you need in the bill generation?
Yes, sir. In actually bill generation, na, they are coming over here. Na, that people are coming, they taking the images, capturing that images, and then they are doing manually. Means they are entering into that system, and then we get. So why not to use directly? Because from the first side we are capturing that image, na, from the sensors. So we got that readings. So directly use it for the bill generation. That's why.
Okay, fine, fine.
Yes.
So very nice. Okay, you can go ahead with your presentation, with your research. And as I suggested, you just go through some existing literature on the what are the actual limitations in the real implementation of the material. Okay,
Yes,
then
sir.
only we can improve the things.
Yes, sir.
So
Thank you.
my best wishes to you. All the best.
Yes, thank you. Thank you for your suggestion, sir.
Thank you so much, Ms. Poonam. And our next presentation is from Ms. Monica Arya, and her paper is about a novel deep ensemble learning framework for classifying imbalanced data stream. Hello, Ms. Monica.
Yes, ma'am, I'm presenting my screen now.
Yes, sure.
Ma'am, is my screen, sir, is my screen
Yes, yes,
visible?
it's visible.
Yes, sir. Good morning, sir.
Good morning.
Sir, myself, Mrs. Monica Arya, and I am from Billa Institute of Technology, Durg. And I will be presenting in the topic, a novel deep ensemble learning framework for classification of imbalanced data stream. Sir, my paper ID is 527. And the authors for this paper are, it is me, that is Monica Arya, and my guide, Dr. Hanuman Shastriji from University of Petroleum and Energy Studies. And so this will be the flow of my presentation. First, we'll discuss the abstraction part, then some introduction, the challenges and open issues which I have detected during the literature survey, then the proposed framework, that is the deal framework, the experimentation and the results which we have done, and the conclusion part for the work. So sir, in the abstract, I have discussed about that mining the imbalance stream is a research demanding subfield in this area. So a balanced data stream has been mined very much, but mining the imbalanced data stream, now it is getting the popularity. So basically the imbalanced data stream is one in which the target class, it has a much less instance than the other class. So there may be two or more classes, and one class may have very less instance. So that can be the imbalanced data stream. So the performance of the classifier, it is affected by variety of imbalanced data set used for training the classifier. Most of the traditional data algorithms, they misclassify the minority classes and the imbalanced data sets, or it considers the imbalanced data set to be a noise. Like it considers the minority class to be a noise. So therefore, the decision is biased. Generally, the decision is biased, and the majority class, it wins. And hence, this reduces the accuracy of the overall performance. Now, in this paper, I propose a framework which is specifically for imbalanced data stream. And here we are using the deep learning approach along with the ensemble learning approach in order to classify the imbalanced data stream. So the deep ensemble method, it will help us. The ensemble method, it has a multiple base classifier. So while the deep learning approach, it is applied to improve the performance by extracting the lower level features. So we are combining the benefits of the ensemble based classifiers method also and the deep learning method also. And here we are classifying there, and thereby we are classifying the imbalanced data stream to get more accuracy. In this method, the effect of highly imbalanced class is reduced by utilizing the imbalance method with deep learning. So in addition to the accuracy, the other performance measures also we have taken, like categorical prediction accuracy, which is very important while classifying the imbalanced data stream. Then the training and the prediction accuracy, which have been compared with the crucial metrics for evaluating the imbalance stream data. So coming to the introduction part. Okay, now coming to the introduction part, first of all, we will discuss about the traditional machine learning algorithm. So most of the traditional machine learning algorithm, they assumes that the data is already in the balance mode. These models, they focus on the majority class characteristics and neglects a minority class example. But this minority class examples, they are very, very valuable in case of very critical areas, like suppose in medical fields, then in credit card fraud detections, where we have where we may have among 10,000 or 1 lakh transaction, we may have one fraud, or all the positive cases, then we may have very less negative cases in medical data. So in case of such imbalance, we need to have algorithm which classify these very accurately. The traditional machine learning algorithms, it may consider classification frequent classes and reduce the overall performance and the accuracy of classifiers. Sensitive type medical diagnosis.
Monica, your voice is not clear.
Ma'am, I guess there is a error in your internet connection. It is very disturbance. Hello, ma'am.
Monica, are you there?
Sir, am I audible?
You are audible, but your voice is not clear. I think you can check your network connection. Have you opened the Chrome and other browsers also in your desktop? You can just close them.
No, sir.
Okay. Maybe your network is very slow.
Sir, is it audible now?
Yeah, now it is audible. Yeah, please go ahead.
Yes, sir. Okay, sir. So the experimental, first of all, we have experimentally compared some state of arts ensemble classifiers for synthetic imbalance data for binary classification problem. So here we have taken the 10,000 samples with imbalance ratio of 99:1. So we have taken a high imbalance ratio, and the ensemble classifier is compared on the basis of ROC AUC square. So we have compared some very basic state of arts ensemble algorithm. Okay. So now we will discuss some deep learning strategies for handling the imbalanced data sets. So there are two techniques for handling. So deep learning uses two techniques for balancing the imbalanced data set. That is the balancing the weight, and second is the sampling. So sampling here we have compared the base models, weighting models, and the sampling models. Here we have experimentally compared it. So here it is very clearly visible that the basic model, it has more accuracy than the weight balancing model and the sampling model, but the recall value is less. So this clearly indicates that the ability of the weight balancing and sampling model to detect the false positive case is more than the basic model, which is very crucial in the imbalance dataset class. Now, next we will discuss some of the challenges which I have identified during my literature survey. The first challenge is that the traditional machine learning technique, it evaluates the performance of the classifier by confusion matrix. Generally, we take out the confusion matrix and evaluate its performance. It only gives information about the actual and the predicted classes. But for the imbalanced data set, it is not enough to measure the performance of the classifier. We need some more matrix in order to evaluate its performance. Second is that the imbalance of the class may vary across the problem domain. If it may range from slight imbalance or to severe imbalance. Like the traditional machine learning techniques, they can get a good results where they have very slight imbalance. Okay, like 1:4 or 1:100. However, in real life problem, we generally have a severe imbalance problem, like it may range from 1:1000 to 1:5000 and even more. So such severe imbalance is challenging to model and it requires specialized techniques. So these are the challenges which I have identified. Now, there are some open issues which need to be addressed when designing the new algorithm for classifying the imbalanced data stream. So one of the challenging issue while designing the new algorithm for imbalanced data set is dealing with new emerging classes. So with data streams, we have the new emerging classes which are and we have the old fading classes also. So in both the cases, naturally the classes which will be emerging new or which will be fading, they will be the minority class. Okay, so another vital challenge in classifying the imbalanced data stream is the availability of the class labels. So new emerging class, they do not generally have the class labels, and the traditional machine learning algorithm, they assumes that we already have the class labels when we start classifying. So however, in real life scenario, it is not true, and also impose the labeling cost on the system. So while designing the new algorithm for imbalanced data stream, new labeling strategies must be developed. So first thing is that the minority class, and second is that the new labeling strategies must be developed. Third open issue is that a very common recurring drift problem in the data stream. So in data streams, we have a recurring drift problem. That is reappearing sources can also be the reason for the class imbalance. So as such drifts occurs again and again over time, developing the dedicated method for such scenario and storing general solutions for reappearing classes is required. So all these three are the open issues, and concentrating on these issues only, I have proposed my framework. Now this is the framework which I have proposed. So in this work, we have proposed an algorithm, that a framework, that is the DEAL framework. with novel deep ensemble learning model is proposed here. In this approach, we have combined the deep learning and the ensemble approach both. Okay, for classifying the imbalanced data stream for the real-time data stream.
Sorry to interrupt you, ma'am, but 1 minute left for your presentation.
Okay, so the steps for the deep learning ensemble is the feature generation, feature extraction, and tensor transformation. These are the general steps. Now, this is the main part, that is the model building part. In this part, we have utilized the DEAL framework, which is having 5 layers. The 3 layers are the internal layers and the input and the output layers. In the internal layer, we have applied the ReLU as linear functions. And in the outermost layer, we have applied the sigmoid as it is used for the binary class classification. Then the last part is that the extra tree ensemble learning and optimization. The proposed method utilizes the number of features to optimize the probability scores, and the majority vote is the final prediction or the classification. So here we have ensembled it, and we have used the majority vote ensemble method, and the majority vote is the final prediction. And the score function cost or the cost function used is the binary cost entropy or the log loss. Here is the flow chart. So first we have done the subset generation for the features. Then the candidate subsets, the features are selected. Then we choose the best, and the pre-processing is done. And then we apply it in to train the model and to test and validate it. So these are the experimental results. We have compared it with state of art like CNN and MLP. We have compared our proposed framework with both of them. Now, the conclusion in this work, the performance of the traditional ensemble algorithm for classifying imbalanced data stream has been compared, and the novel deep learning framework has been proposed and the methodology is discussed. In addition to accuracy, the other performance measures like categorical prediction accuracy, training accuracy, prediction accuracy have also been suggested and compared. So these are the references of my work.
Okay, Monica, it is done.
Yes, sir.
So it is the first paper in your research for this research?
Sir, it is a classified selection for highly imbalanced data stream with minority driven ensemble.
Okay, fine. I think your work is nice. There is no problem. So you mentioned all the existing mechanism. Then you have also presented your proposed model. So I think it's okay. Good. Nice to go. No questions from my side.
Thank you, sir. Thank you very much, sir.
Thank you so much, Ms. Monica. So as our all of the presentations are done, I'm moving ahead with our closing remarks. I sincerely thank our authors for their excellent presentation in this session, and all other past participants for being the part of this international conference. I hope this session was informative enough. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live in 5 to 6 months, within 5 to 6 months. So kindly cooperate with the team of ICTIS 2021. I also thank our session chair, Dr. Vijay Singh Rathod, for chairing the session, a token of appreciation to the chair on behalf of ICTIS 2021 and Global Knowledge Research Foundation. Thank you so much, sir, for chairing the session.
Thank you so much. Thank you so much.
Okay, so at last, I would like to request all to on the camera so I can take a quick snapshot of our virtual conference. Okay, never mind.
Presumably your face is not visible properly.
Fine. Thank you very much, everyone. Stay safe and take care. Bye, sir.
Bye bye.